All right, welcome. I'm making this video by request, and it's discussing how coefficients in a chemical reaction can be molar ratios. All right, so a chemical reaction. Any chemical reaction has certain reactants. Those molecules rearrange to form products. We've studied a lot of chemical reactions already in IB chemistry. Let's take one that we saw in organic chemistry, for example. I'm going to look at the combustion of methane. And just like in any chemical reaction, I have certain reactants. I'm actually going to draw these as well. I have certain reactants. The bonds in these reactants break to form new molecules. So now in my products, I have my oxygens bonded to a carbon, new chemical bonds formed to form new products. So any chemical reaction is the rearrangement of atoms to form new molecules. Hopefully we feel pretty comfortable with that. That's what we see here. We've also already seen that chemical reactions need to be balanced. Why? Well, because a chemical reaction cannot create or destroy a new atom. That's the law of conservation of mass. You can't create new matter or destroy matter. So, if I have 4 hydrogens on the left, well, I better have 4 hydrogens on the right. I need to add more hydrogens. The only way I can do that is by having more water, because water is the molecule in which I find hydrogens. I need 2 water molecules. All right. I know it should be balanced. Whoops. Carbon on the left, 1 carbon on the right, and 2 oxygens. 1, 2, 3, 4 oxygens. So in order to be balanced, I need to add a 2 here. I went through this a little quickly. I'm hoping that we're feeling pretty comfortable on what a reaction is, how to balance reactions. If not, you have lots of resources on this idea that I've just covered. There's resources from the organic chemistry unit. There's resources that I can send you. You can send me an email. So the focus of this video is not what a chemical reaction is, but if any of what I said was confusing, you should reach out to me for extra help. All right, so I have my balanced chemical reaction, and that tells me for every 1 CH4 molecule, I have 2 oxygen molecules that produce 1 CO2 and 2 water molecules. Well, I know that if I started with 2 CH4 molecules, I would then need, how many oxygens? I need 4 oxygens. To make, now I'd be able to make 2 CO2 molecules and 4 water molecules. Well, what if I started with 6.02 times 10 to the 23rd CH4 molecules? Well, then I'd need, in order to do a complete reaction, I'd need 2 times 6.02 times 10 to the 23rd molecules, oxygen molecules, to produce, let's see, 6.02 times 10 to the 23rd carbon dioxide plus 2 times 6.02 times 10 to the 23rd waters. Of course, writing out that number each time is a little silly, but I see that even once I scale up to moles, these coefficients are going to be the ratios of reactant molecules and product molecules that I need. So for every 1, because that's my coefficient, CH4 or why don't I write it like this? 1 mole of CH4 and 1 mole of, 2 moles of oxygen that react. And I'm getting these numbers from the coefficients, 1 and 2. I have 1 mole of CO2 and 2 moles of H2O produced. So I'm seeing that coefficients can serve as molar ratios. Let's see what this looks like in practice. I'm going to work through number 6 from the homework. Calcium carbonate decomposes of a decomposition reaction when heated, producing calcium oxide and carbon dioxide gas. Great, and they give me the equation. When 50 grams of calcium carbonate was decomposed by heat, how many grams of oxide should be formed? All right, so starting unit. The only amount that I have here is this 50 grams, so that's what I'm starting in. 50 grams of calcium carbonate. Ending unit. What unit do I need to end in? Grams of calcium oxide. Grams of calcium oxide. Well, am I able to convert directly from grams of one thing to grams of another? I am not. How do I change from units of one thing to units of another in the same reaction? Well, I need to use moles. So I'm going to start with the grams to moles conversion for calcium carbonate. I am then going to use my molar ratios. I see I have 1 mole of calcium carbonate for 1 mole of calcium oxide. I then also will need to go from moles of calcium oxide to moles of, 2 grams of calcium oxide. All right, so hopefully you can set this math up on your own at this point. That would be my expectation. We can do it here together though. Let's check the periodic table for calcium, carbon, and oxygen. I'm going to check the periodic table I have here on my iPad. You should, of course, use the periodic table that you have in your data booklet. Calcium is 40.08. Grams per mole. Carbon, I happen to know this one off the top of my head, is 12. Oxygen is 16 times 3. So calcium carbonate, my molar mass is, I'm doing this here in real time. Hopefully you already have this calculated for yourself. These two together, 52.09. All right, I'm getting 100.09 grams per mole for CaCO3. For calcium oxide, I have 40.08 plus 16. 40.08 plus 16, 56.08 grams per mole. All right, so to finally set up this problem, we'll start with 50 grams of calcium carbonate times 100.09 grams of calcium carbonate, 1 mole of calcium carbonate. Here's this new molar ratio we've learned. In this case, it's just 1 to 1. But you still need to write it because it's not always going to be 1 to 1. Times 1 mole of calcium oxide 56.08 grams of calcium oxide. All right, I'm going to leave you there. I trust that you can plug this into your calculator. I hope that this was a helpful, quick review of molar ratios. As always, let me know how it can help and what questions